We're going to start page 15 now. The example here talks about tangent lines. What is a tangent line? So imagine you got like a round hill, and then you're going to put a board against that hill. If you have a perfectly round hill and a perfectly straight board, theoretically this blue board is going to touch the red hill at only a single point. Okay? And that is like a tangent line on a curve. A tangent line on a curve touches the curve only at one point. So what we're going to do now is we're going to use discriminants to figure out what the equation of a line would be if it was against a curve at a certain point. Okay? So why don't we try that? Number 2. Use a graphing package or a graphics calculator to find the coordinates of the points of intersection up to 2 decimal places of the graphs with equations. And they give us a couple equations here. So let's get out the calculator. We're going to program both of these functions into the calculator. So we go to the y equals screen. We press x squared minus 3x plus 7. And then the other function is going to be x plus 5. And then we're going to graph them. There's the parabola, and there's the line. And we're going to find the points of intersection with up to 2 decimal places by doing second calc intersect, number 5, and first curve. Now it's going to ask you first curve and second curve. We only have 2 curves here. So if you only have 2 curves in there and they're asking you if this is the first curve and the other one is the second curve, of course they are. So you just hit enter twice. And then it asks you to guess the intersection point. Now this is kind of important because we want to know the left intersection point or the right intersection point. Let's start with the left intersection point. So the cursor is already close to the left intersection point, so I just press enter. And it gives me that the intersection is 0.58. It says 2 decimal places, but I'll go to 3. 586, comma, 5.59. Okay, so that's the left point. Let's find the right point. So we repeat second calc intersect, number 5. First curve, yes. Second curve, yes. Guess, enter. Oh, I forgot. I need to move it over, sorry. See, that's the problem. If you don't put it close to the second intersection point, it's just going to find the first one again. First curve, second curve, and then I move the cursor over with the right mouse button. Move the cursor over toward the second intersection point. Hit enter. So the second intersection point is actually 3.41, comma, 8.41. So there's 2 intersection points, which we found both with second calc intersect. C. So now there's 2 others. We're going to repeat the procedure here. So the first thing we're going to do is we're going to clear out the old ones. Clear, clear, clear. Whoops. Clear. Oops. Clear. It's a little bit delayed. Okay. Negative x squared. Now remember, when you press negative, make sure you use this one here, not minus. Okay, they're different. Whenever you have a leading negative sign, you're going to have to put the negative sign. Negative x squared minus 2x plus 4. And then the next function is going to be x plus 8. Graph. Really? So they don't intersect? Interesting. So let's just make sure that I typed it in correctly. Negative x squared minus 2x plus 4. Yes. X plus 8. Yes. So, okay, they don't intersect. All right? All right. Let's go down to 3a. Find where y equals x squared meets y equals x plus 2. Okay, this looks easy enough to do without the calculator. So the point where these two meet can be found by equating the y's on both sides, which means equating the right side of each one. So for example, if these y's are the same, I can make the right hand sides, which are also equal to y, equal to each other. So I'm going to do that. I'm going to say x squared is equal to x plus 2. And when that happens, those are the intersection points of the parabola and the line. So to solve this, I need to make it into a quadratic all on the left side equal to 0. I just subtracted x and 2 to the other side. Now I can either factor or find the solutions by doing quadratic formula. I think x minus 2x plus 1 is the factored solution. The two x values that make this statement true are x equals 2 and x equals negative 1. Okay? Alright. The y values that correspond to these x values are, now I need to go back and put 2 back in here, for example. I could put it in x squared also. Either way, I'll get 4, right? So 2 comma 4. And negative 1 plugged into either of those equations gives me positive 1. So those are the y values that correspond to the x values. Now it says to solve for x when x squared is greater than x plus 2. Okay. So now we draw a number line. And when x equals 2 and when x equals negative 1, we know that x squared is equal to x plus 2. And when in between those two circles, or to the left or right side of those two circles, it's either going to be always minus or always plus. We just need to test out one point. So let's test out the 0 point, and let's test out positive 100 and negative 100. And then we'll see if at these points the result is positive or negative, and that'll tell us when x squared is greater than x plus 2. Okay? So for example, if I plug 0 into this equation here, I'll get negative 2 times plus 1, which is negative 2, right? So in between negative 1 and 2, we know that all these values here are 0. Or all these values here are negative. If I put 100 in here, it'll give me about 98. If I put 100 here, it'll give me 101. Two huge positive numbers multiplied together give me positive numbers. So this part is positive. And last of all, if I put negative 100 here and I put negative 100 here, I'll have negative 102 times negative 99, which is two huge negative numbers multiplied together give me a positive number. Okay, so now I know that either one of the sides neighboring the yellow region are going to make this side positive. If this side is positive, that means x squared is slightly bigger than x plus 2. So the positive regions are the ones that are the solutions for this problem. So when x squared minus x minus 2 is greater than 0, that is when x squared is greater than x plus 2, right? That's what they want to know. So basically, it would be when x is greater than 2 or when x is less than negative 1. Okay? And I need to put or there because x cannot be both greater than 2 and less than negative 1 at the same time. Okay. Let's check out this next one. Find where 2x squared minus x plus 1 meets 2 plus x squared. The way I do that is I set them equal to each other, just like I did before. Okay. Then I'm going to combine like terms. So I'm going to subtract x squared from both sides. So I'll get x squared on this side, and I'll get 0 on this side. I'm going to subtract 2 from both sides. So I'll get plus 1 on this side, and I'll get 0 on this side. And then I'm going to subtract x from both sides. So I'm going to get 0 here, and I'm going to get minus 2x here. Now, I'm going to use factoring to solve this one. This factors into x minus 1 squared. So that means at x equals 1, I have a solution to this, which means the intersection point is going to be at x equals 1. By the way, what is the y-coordinate when x equals 1? That'll give us the coordinates of the point where this parabola meets this parabola. Wow, it's two parabolas meeting together. Cool. If I put 1 in here, I'll get 2 plus 1 squared, which is 4. So the coordinate is 1, 4. Okay. So I know that when x equals 1, this expression here is 0. When is that expression positive or negative? Okay, so if I put in a number greater than 1, such as 100, I'll get 100 minus 1, 99 squared. That's a big positive number, so this will be positive, right? What if I put in a big negative number, like negative 100? Negative 100 minus 1 is negative 101. Squared is big positive number. So on either side of the 0, it's going to be positive. The only place that it's not positive is going to be exactly at x equals 1. Okay? So when is 2x squared blah 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 greater than this? Well, that happens when this expression here is positive, because what I did was I took the left side of this and I subtracted the right side of this. So if I do one subtracted the other and I find out it's positive, right, then that is going to give me the regions where this is true. So basically, this the statement is true everywhere except for x equals 1. So my answer for this is x is not equal to 1. And that's it. Every other point works. Okay, and that is page 15.